Hey kids, something a little bit different. These are a series of questions that were asked of students that were competing in the Math Olympiad competition over the years. So I thought they were kind of interesting, and they worked in different areas. And I thought you might kind of enjoy trying to take on these different challenges. So each one is very different. I thought I would just quickly go over what they are asking you to do so you can kind of make sure you know what you need to answer. So the first one, it's a puzzle where it says, and be sure you see this, the odd numbers from 1 through 17 are placed in the magic square. So think about the odd numbers, 1, 3, 5, 7, 9, 11, 13, 15, 17. Right? So those are the numbers that you get to choose from. And you're going to use each of those numbers once. Okay? All the odd numbers 1 through 17. And they're placed in this so that the sum of the numbers in each row, column, and diagonal are equal. What number goes in the square marked X? So what number goes in this spot right here? So that if you add up your numbers in each column, they're the same. The sum is the same. The sum of each row is the same, and the sum of the two diagonals is the same. So yeah, you'll kind of need to maybe do a little guessing and checking. Right away, I mean, you can see going across this row, you got 13 and 5. So you know your sums have to be more than 18, because those two numbers are 18. You need another number here. And you've also already used 1 and 3 and 5. So the smallest number you could put here is 7, right? So the sums have to be at least, 7 plus 13 is 20, and 5 more is 25. So I'm not saying that the sums are going to be 25, but just know that with the numbers that are already out here, they got to be at least 25. So think about that. Remember, every row, every column, every diagonal has got to be equal. What number would have to go there? The next question, what number can be placed in the square to make this statement true? So 3/5 is less than this fraction, and this fraction is less than 4/5. So what fraction with a 7 as our denominator would be greater than 3/5 but less than 4/5? I gave you a little hint here. It might make sense to find the equivalent fractions where all three of these fractions has an equal denominator. That might make it a lot easier to figure out what's got to go here. But good luck. Next one, in the figure, all angles are right angles and all distances are in feet. What is the area of the figure in square? Oh, we shouldn't have done that. Let's change that. If they're in feet, then we should keep it in feet, right? So it's always in feet. What's the area of this figure total? I would say there are two ways that you could do this. You could either divide up this shape into easier shapes that you can work with. So like if you kind of imagined or drew in lines to make a series of rectangles that are in here and solve it. Or what you could do is figure out, like, let's say you finished off that section and this section, like you added it in, found out the area of the entire rectangle, and then took out those pieces that are missing. Either way, I want the area of this entire composite figure. The next one, Mrs. Allen spends 3/5 of her money at the grocery store. Next, she spends 3/5 of her remaining money at the gas station. She then has $8 left. How much money did she start with? So you need to figure out a number that after you take 3/5 of it and then take 3/5 of that, it leaves you with $8. So how much money did she start with to leave $8 left? Next one in the figure shown, two squares share a corner. Share this corner up here, A. The larger square has an area of 49. So this black square has an area of 49. The white square on the inside has an area of 25. What is the perimeter of the shaded region? So if you add up the lengths of these sides, what would that total be? Now, I gave you a hint on this one. If you know the square's areas, you should find the length of their sides and go from there. They're squares. If you know that this little square here, the area is 25, you know how long its sides have to be. Remember, area is length times width. So this times this is 25. What does this area have to be? You know, the big one is 49. So you know the length of this and the length of this multiplied together give you 49. So what do those have to be? Then you can figure out the lengths of all of them. Solve from there. Number 6, we got an addition problem. 345 plus 678 plus cat equals 1,205. What does cat, C-A-T, what number is that? C is a digit, A is a digit, T is a digit. What does that have to be to make that true? 7, pretty straightforward, kind of an algebra problem. 1 hat and 2 shirts cost $21. 2 hats and 1 shirt cost $18. So that price of the hats and shirts are the same in both those situations. You got to figure out what those costs are for that to be true. And then Megan has exactly enough money to buy 1 hat and 1 shirt. How much money does she have? So once you figure out how much a hat costs and how much a shirt costs, put them together and you'll get the total amount. And lastly, Tracy's Trophies, it's a little store, charges by the letter for engraving. So each letter costs an amount. There's one fee for each vowel and a different fee for each consonant. So the vowels cost one amount of money and the consonants cost one different amount of money. You know your vowels, right? A, E, I, O, U. So it says Carol costs $31 to engrave. Gabriel costs $43 to engrave. So looking at Carol, I see 2 vowels and 3 consonants. All that together gives me $31. Gabriel, I see 3 vowels and 4 consonants, and that together gives me $43. So using that information, I want to figure out how much a vowel costs, how much a consonant costs, and then I can apply that to the word Bridget, and then I can figure out the total cost of that. But that's it for your Math Olympiad Puzzlers. I hope you like these types of math problems, and I hope you do a good job.